initialize Genesis sequence.
So, good morning, everybody. I see there's plenty of chairs still upstairs there. Thank you all for being here so early. I didn't expect so many people. That would make me a tiny bit nervous, but that's okay. Today, we're going to be talking about code reviews. And specifically, actually, just about code reviews. So my name is Paco van Beckhoven. I work as a software engineer at Hexagon's Innovation Hub. They were kind enough to sponsor me to be here. And I work on a product called HXDR, which is a sort of a cloud-based platform that allows users to create and explore large 3D models and from the browser. And we do a lot of cool things with data, geospatial data. But that's not important, actually. Most important is that I like code quality. So I've been going to conferences, and I really like to talk about the developer experience and how to, well, improve this, which is also the reason why I'm here. Now, to get started, yes, this all works, great. $360 billion was the annual cost of fixing bugs in 2013, according to research by Cambridge students. It should be added there. This included the time of finding and fixing bugs. Now, if we add the necessary inflation to this, you'll come to a number that might save plenty of, say, world problems. So something that we might improve on. And one of the ways to do this is through fixing bugs earlier in the development phase. Because as we all know, the longer it takes to spot a bug, the more expensive it becomes to fix it. And especially, for example, if a bug already made its way to production, well, before you find it, you fixed it, you have to go all the way back. It costs a lot of time. Now there's many ways to spot bugs early. But for now, we're going to be talking about code reviews, which take place approximately in the coding and testing phase. So what is a code review? Now, I would say it consists of three important parts. It's about finding and fixing bugs. So being able to catch bugs early, and this is where we sort of save the money, but also a lot of frustration and also reputation. But there's more to it. It's also about learning and coaching. We share knowledge through code reviews. We learn new things from each other, but also we can mentor each other, and it also helps us with co-ownership. And last but not least, it improves code quality, which I think deserves a definition of its own. So code quality, I would say, is about making code more readable, more efficient, in line with the company's standards and conventions. So this all sounds pretty good, right? Do we like code reviews? Great. So nobody, right? So of course, there's the necessary nuances, right? If you invest heavily in pair or more programming, if you have a very high-skilled team, probably other excuses to figure out, but in the end, it's not a bad thing. So now the question is, how can we efficiently incorporate these code reviews into our development practices? And the answer for this is pull requests. So now I want to do another show of hands. Pull requests or merge requests? Pull requests? And merge requests? Are these all the GitLab users? Right. Just to add a small note here, I'm also on GitLab. I have been indoctrinated to switch to merge request, which means I will and might switch them. They both, to me, they are the same. So pull request, merge request, they all do the same thing. Now, these things are facilitated by most version control systems. Tools like GitLab, GitHub, whatever you can think of, they allow you to do code reviews. They allow you to create them, create these pull requests, to review them, and they also contain useful integrations and other features that help us review. And even though we have these great tools to help us, we often see the less pretty side of code reviews. There's, for example, the great pull request that changes about 50 files, that has the very good title and the even better description. But there's more. There's the awesome feedback that we receive from people, which is also not very helpful. The fact that you ask for reviews, but nobody's responding. And last but not least, the curse of the small pull request. It's better to just format 40 files, and then you're for sure that you get a review if it looks good to me in 5 minutes, rather than 10 people doing that. But of course, this is not how we're going to do this. Now, one of the ways to address these issues lies in creating good review-friendly pull requests. So that's where I want to start off with. And for this, we're going to assume that all the changes, because that's out of scope for this presentation, are concise, they're focused, they're tested, you did all you could. to write the code correctly. And it's good to assume that people come in blank. Because maybe you have context, maybe one of your team members has context, but you in half a year won't have the context anymore. And then you'll be very grateful to be able to look back and see why certain decisions were made, for example. Now this starts with a good title. And a good title should be self-explanatory, like a good commit message. This is not a good title. But if you add the right amount of context, you get a better title. And we can take it even a step further, because as I said, it's like a good commit message. So why not adhere to the conventional commits? For those who don't know conventional commits, it's sort of a standardized way of, well, writing commit messages. And usually a pull request title often ends up as the final commit message, especially if you squash things. So why not do it here as well? And you can do linting in your VCS tool. It's quite helpful. And also always don't forget, include the ticket reference, because most VCS tools also make it clickable, and it's great for making sure that you can easily navigate through what's going on. And of course, then there's the description. So C title, also not a good description. You want to start with adding some context, which is usually the extension of the title, things that people should know. Maybe there's more, there's some documentation, maybe some background on the feature you're implementing. Then you should describe what did you change in this pull request? And it doesn't have to be literally anything, but just a small list of what people can expect. Like, hey, I made some changes to the database and maybe remove some unnecessary fields so that people know, okay. Now what's more important, I think, is the why. Why did you choose a given approach while implementing this feature? Because when you were writing or creating this pull request, you went through a certain thought process. You made decisions like, okay, I tried this, and now that wasn't the best idea. I tried this. This knowledge is there now. This knowledge will also not last forever. And the reviewer might also find this very interesting, because then they don't need to ask questions about it. And another one, the examples. For if you work on the front end, add some screenshots of the feature you added. It can be quite helpful for the reviewer to see sort of, again, what to expect, but also for the backend, we can also do this. We can create an example request and response, which can be very helpful for the person testing. You can add a database query with the database results. All these things can help with reviewing and seeing what to expect. Now the challenge is to keep this all concise and readable. And I think at Devoxx we have seen plenty of talks about AI. I think this is a great candidate to use any of your local LLMs or maybe ChatGPT to make it at least a bit readable, because nobody likes a big wall of text. And to help you with this, most VCS tools also support templates. Please use them. Because it makes the text consistent across repositories, across pull requests, and it helps people then to find the right information faster. And what I particularly like about these templates is the use of checklists. Because not every pull request, for example, needs to have an update to the documentation. So it's always a good reminder that maybe it's 1 out of 10 pull requests that actually, the other 9 are bug fixes or maybe small changes. But that one that actually does it, then it's a good reminder to have some checkbox as a reminder. But also for common pitfalls you haven't automated yet, or what I particularly like is things like, I tested these changes. It's a very good second reminder that if you're creating this pull request and you try to get out of maybe taking a shortcut, that you actually deliberately have to press the button and say, I did not do my work correctly, or you actually have to fix it. That's my personal favorite, at least. But yeah, use templates. And do note that, of course, not all these issues, etc., justify such large descriptions. Some small bugs, you don't need to write the whole story. But even then, even for the smallest hot fixes, write something down what's going on, because a version upgrade and fix bug, it's just not helpful. Don't do it. Now that we've created the pull request, I think the next step we can do is to start reviewing our own code. This is something that I learned, and I found it quite useful, because you get sort of your own fresh set of eyes. You look at your code from a different perspective, usually from your VCS tool, for example, and then you quickly start noticing, like, hey, why did I make changes to this file? You see some leftovers, maybe from a previous solution, some fields that you forgot to give a correct name, maybe some typos in the Java doc. Usually, for me, I find like at least 3 or 4 extra commits of some tiny things, tiny nitpicks that I would like to do on myself. But it also allows you to add context to smaller changes. For example, I came across a file that turned out to be not used, or I thought it wasn't used, so I did some research to verify that it wasn't used. This research that I did can be very helpful to also write down, because then the next person who's reviewing this now also knows, hey, I don't have to do this, because I mean, if I would look and I see a file deleted, I'll also be wondering, should this file be deleted? And then I go to do the research again. That saves time if I just write it down. It makes it easier for the reviewer. You can also use it to highlight the important parts. So writing, and I'm still talking about adding commands to your own pull request. For example, you fixed a bug in a file for which the previous developer didn't format it. And then there's a one-line bug fix in this gigantic file with, say, 50 lines changed. And then it's hard for the reviewer to find the actual important part. If you just add a small comment there saying, okay, this is the bug fix, it can be a lot easier for the reviewer. And it's also a nice place to ask specific questions. So if you want to, within the context, hey, I'm not really sure about this name or maybe this implementation, or ask another team, hey, this is the part where I integrate with your service. What do you think about this? This is really good. So now that we've reviewed our own code, I think we have established that we created sort of a review-friendly pull request, because we helped the reviewer already ask some questions and answer them. Now, we need to get people to actually start reviewing this. And what you see is that in an ideal world, teams proactively check for pull requests. There might be round-robin assignment, people check it themselves. It's standard procedure. But in practice, you see that people don't really like to do code reviews, because you have to do switch context and everything. So this is a way it could work. I would say it's not very efficient. What does help is to take a look at this message and why it's wrong. So the first thing that I would say, this thing called diffusion of responsibility. If you throw a message like this in a Slack group, then everybody thinks that everybody else will do it. And that way nobody will do it, and it will take a long time. Instead, target specific people. So whenever you have a change, either somebody you know, and maybe who've worked in this area, maybe tech, just a random person, if you don't know, and that random person is more likely to respond and point you to the right person rather than not responding at all. And what also helps is to add some context, because you might be working in an area that somebody else is also working in. So that makes them more likely to quickly review it, because, hey, oh, this is I need this. And a deadline. Add some sense of urgency. That also works. Like, okay, I need this done before the end of the week, or I need to have this done by the end of the day because this is a hotfix. That also helps. So in the end, a message like this, where we add some context, some review, and we add some extra fluff to make it sound more friendly, is more likely to get picked up a lot faster, if this is the way you do your reviews in your company. Now, this actually goes further than just code reviews. This is about asking for help in general, actually. If you need some information from another team, maybe you need some statistics or anything, try to tag specific people instead of throwing messages in the Slack channel, hoping that people respond. Now, hopefully people are looking at a pull request. The next step is to deal with their comments. And this doesn't always go as expected, right? Some people simply lack social skills, but there might also be cultural differences at play. So I always like to take myself as an example. I'm from the Netherlands. I think there's a lot of Dutch people here, right? Yeah, plenty. Okay, so we're known to be quite direct, which also means we might come across as unfriendly for other cultures, and which means that either we need to add some fluff to our messages, or it's also good for the other people to realize that, okay, this is a cultural thing, it's not personal. This is just the way we communicate, which might help. In the end, it's important to be patient and to try to always be the bigger person, because that's what being a professional is about, that even though the tone might not be nice, try to go past that and just look at it. Don't make a big fuss about it. Now, there's more. There's also fake feedback, right? And it's super annoying. Can you approve this? What did this person mean? And you can either go through some trial and error trying to figure out what he meant, or she. Instead, just ask what they want. Because why would you waste valuable time trying to figure out if they probably know what they want? Because, I mean, otherwise they wouldn't say it. And about not wasting time, we have these endless discussions. If there's two people with a strong opinion in the team, then you're known that, and they are very on the nitty-gritty, then, yeah, you can have a lot of discussions. So the first important one, I think that everybody knows this one, and keep repeating this to yourself. Pick your battles. Not every tab or white space is worth a fight. But if you're convinced that something is wrong and the other person is convinced that something is right, and you're at the 20th reply in a thread, then maybe this is the point where you should take it offline. Because it's not efficient. It's an asynchronous way of commenting and it takes a lot of time. But if you take it offline or in an online meeting, please report back, because this is also what we often do wrong, is that we take it offline and then we have some discussion and then we take the conclusion, we use that conclusion, but we don't write it down necessarily. And then you get back into this issue where half a year later you look back at this pull request and you realize, oh, why? And this also goes, again, for regular messages on Slack, on Teams, whatever. If you have a long discussion, you take it offline. Just write a brief conclusion. It's not a lot of work, and it's so helpful also for the other people that are looking. Now, of course, all the messages received, not all of them will be bad. I hope there will also be a lot of useful things. You will learn things. And rather than just resolving everything or saying fixed on every single one of them, try to sometimes add some positive notes there as well, because it could be that you learned something. Just write that down. And why? Because this positivity also helps new team members, for example. Say you have a junior in the team that finally started reviewing and he found something, and you say, oh, thanks. But if you could elaborate a bit more, that might motivate them then and make them more, how do you say that, confident. Thank you. They make them more confident, which is good for their, they will start reviewing again and again. And it's also good for the company. Friendly message goes a long way. Now, okay, we have now gotten the reviews. Let's switch seats. Let's go to the reviewer side. And there's two things that we should consider here. The first one, don't wait too long. We all know that the longer you wait, the more context has to be switched every time, because we have to go back and forth. Like, I created this pull request, nobody responded, so a day later I'm already working on a new feature, and now somebody starts responding. And then another day later, and then another day later, and then at some point we get merge conflicts because somebody else turned out to have a small 10-line change, even though a lot of comments managed to merge it faster. So what usually is a good thing to do is start the day with a review, because then you're still fresh and you don't have to switch context. Another thing is when you pick up a new task. And at one of the talks, I think it was from KCD, I saw somebody who explained this as, ideally your backlog is prioritized, which means that the task you're going to pick up will have a lower priority than whatever task has already been picked up, which means that the task that has already been picked up should be finished first, which means you should review it, which I thought made sense. Now the other one is about taking responsibility. And what you often see is that whenever with the large pull requests, they look good to me within 10 minutes, I really hate that when I see that. Because, I mean, I did a lot of work. I also like to hear somebody's opinion about it, and maybe I missed something. And what helped me is always to say, reviewing, approving is about taking responsibility. It's about being a co-owner of the change. It's like as if you sign it off with your name under there as well, that whenever shit hits the fan, you're also the one who's going to be approached. And that mindset, that change in the mindset helps you and might help others also to be a bit more precise when reviewing rather than just, okay, next. Now, when we start reviewing, the first thing we should do is get the context. And we just wrote down this very nice review-friendly pull request. And the one thing that I personally hate the most is the colleague that then within 5 minutes starts asking questions that were already answered in my nice description. Read the description, check the specs, get as much context as possible, because that helps you to do a good review. And also try to check any existing discussions already so that you don't have to repeat anything else. It's, yeah, a bit of a waste of time, of course. And then the next step, how do we review? I mean, this is sort of a global order. I looked, Google had a nice document on how to do code reviews, and this is sort of globally the order they come up with. And the reason why you start from above is that any changes or feedback you have on the high-level overview, on the high-level design, will reflect on the lower parts of the lower level of feedback. So if you say, okay, you start with nitpicking about code style and then say, oh, this whole feature is wrong, then all those commands on the code style were sort of useless because the whole thing has to be rewritten. So you start with a high-level overview. Is the functionality in the right place? And then you go a level further. You start looking at the functionality. Is it implemented correctly? Did we miss any scenarios? And then we go further again. The complexity. Is the code readable? Can this be optimized in any way? And then, and I added in bold, we start looking at tests. So repeat with me. We look at tests. Tests, right? Because the problem is that they always get the least amount of love. It's like the little kid that didn't get the attention from his parents that it needed. Because oh, the tests are there, it should run, because they're also at the end of the pull request, so we just reviewed all the files, and then it will be fine. But a bad test suite will also affect you. I mean, I've introduced quite some bugs, sorry, because people missed to add assertions. They were lazy, like, okay, this 20 field Pojo, I just assert the one field I need for this test, and the other 19, it's too much work. Make sure you're strict on assertions as well. Look at them, because this will also affect you. And then at the very end, you can start nitpicking on style and documentation if everything else is fine. Now, what can help you with reviewing our tools? We have tools, and especially I like the left one the most. Tools like GitLab and I think also Azure DevOps and maybe even Bitbucket allow you to inline code coverage in the change overview. And I think that's super powerful, because how many times are we actually going to look at the code coverage report, then back at the changes, then back at the code coverage report? It's a lot of hassle, and to be honest, I didn't do it in the past, but now that I found that this is a way to do it, I find it very useful. You quickly see, okay, this part has been untested. Also for the person who made the changes, it's quite useful. But there's more. There's also tools like Sonar, which can already add some comments in line, so you already save some time here on the reviews. These tools are really helpful. But there's one tool to rule them all, which is your own editor. Because these overviews, so this is a small change, I would say it's not super important, also not super nice. The review only gives you a small piece of the change, but if we actually start looking at this file from our editor, we get a lot more context. So this is the same change, but now from our editor, and now we see that, hey, this constant has become unused. We didn't see that in the overview. We see that there are some fixes to be made, like, hey, this dot equals is equal to an empty string. We can also do is empty. The code coverage, if you can't do it in your VCS tool, you can also do it in your own editor. Oh, and with the nice IntelliJ features, if you check out a branch and you integrate it with VCS, those pink bars show you what has changed, so you can easily navigate sort of what has been changed, and you can easily navigate around. So always, if it's especially with bigger pull requests, take it into your editor and start looking there. I think that's also very powerful. Now, we did the review part. We start writing comments, because there might be something that we don't like or might not be done well. And what we sometimes see is, take this message here. You chose the wrong framework. Use X, that's actively maintained. That doesn't sound nice. I would get defensive when I read something like this. Why? And part of that is because of the U. The U makes it sound personal, or at least, maybe that's my issue. Whereas, if we go about we is about collective ownership and collection. Even though we didn't make the change together, we are in this together, and we, as a team, want the same thing, which is to create nice features and build nice quality. Whereas the direct attack, people get defensive and less likely to cooperate. And the same also goes for these statements. You chose the wrong, or the framework we choose, the chosen framework is wrong. Whereas if we would convert this into a question, why did we choose this framework? You don't risk the chances of being wrong, because, hey, I mean, you just start making bold statements, but if you make wrong based statements, I really hate those people. Sorry. If you ask a question, people are also more likely to cooperate. You also give them a chance to sort of explain why they made a certain decision, and maybe actually it made sense. Maybe it didn't, but then they might also come to this conclusion themselves, which again helps improving the process here. So a message like this, why did we choose Y? I understood that X is more actively maintained, allows people to explain, oh, either, okay, I also saw this, but, or, oh, you have a good point there. I'll improve this. Now there's more. Whenever we had this, can you improve this? Try to be specific in your commands. And try to stay away from words like this or it. Those are also always great sources for miscommunication, because this might have multiple interpretations possible based on what you sent in earlier messages, or it. What I always like to do is to reread my comments and see if there's no other interpretation possible. And often I see, wait, I used it there, but it could be one of those. It takes a little bit of effort, and it takes some getting used to. But on the other hand, as we've seen with code as well, you write it once, you read it 10 times. The same goes for messages. Try to spend some time and make sure that they make sense. And also try to provide an alternative or a solution, because it's very easy to say that the name is wrong, but maybe you want to provide some direction, like, what about X, Y, or Z. Try to make that sort of a rule for yourself to also help with moving forward rather than just saying that it's wrong. Then there's the suggestions. I really like this feature. Most VCS tools have it, and I didn't use it much in the past, but what you can do is you can select some text, and then you can click on the suggestion, and you can make inline changes. Now, this is great for two reasons. The first reason is that you immediately make clear to the person who needs to fix this what or how it needs to be fixed, and usually they can apply these suggestions immediately, which means that they don't have to go all the way into the code base, find the right place, make the change, commit it. I mean, the committing they still have to do, and you don't have to get back at the code review and look at it, or did they implement it the way I wanted? It's really small, but I think it's very useful, and it immediately shows the change. Now there's of course the caveat here that if you suggest new names for things, that of course this won't work because you also need to rename all usages. Now you can of course add suggestions for all those usages, but that might become a bit cluttery. So you might add a message there. And another thing I came across in the Vox days in Zurich is something called conventional commits. We have commands. We have conventional commits, but you can also try to apply this to commands. Now I think this personally is a bit much, but it's a nice way to make your commands consistent and even parsable in theory. So you can say, oh, there's a lot of improvements here, a lot of questions. I think the most important lesson that we can take from this one is the nitpick. It's a way to sort of give your command either it's urgent, it's important, or okay, this is not so important, I think this can be better, and then you can have a discussion in your team, what do we do with nitpicks? Is it up to the reviewee, the person who is making the changes, to decide on whether they're not going to do it, and then there will be no discussion about it. Or you can say that the reviewer is always right, so nitpicks will always be fixed. But at least it gives some sense of urgency. Usually you can say, okay, the person making the changes can also resolve them if they don't like it. We're not going to have a discussion about it, it's just tiny. And last but not least, pull requests are usually quite a negative place, where you only hear what you did wrong. Try to force yourself to also find something positive. This might not be the right way, but I mean, you might be happy about a feature that somebody changed if you cannot find something else. Say thank you for doing this annoying task that I really didn't want to do. Maybe you learned something new. Maybe you thought this was excellent implemented. Again, if we go back to the person that's starting, this adds some confidence. And also in a time where you see a lot of imposter syndrome, right? There it might be useful to actually give somebody an extra compliment, which might help them get confident and more happy. And as we've also seen, I think it was in Tricia McGee's talk, happy people become more productive, which in the end is good for the overall team again. Now I can drink some water. So next, I think we had pull requests covered, so this is great. There's another topic that I wanted to discuss, bike shedding. And bike shedding, also known as the law of triviality, comes from a story about a corporate committee that spent way too much time discussing the bike shed rather than the complex construction project, because it's much easier to talk about the things we know and we like than the things that are take a lot of mental cognitive load. And in code, this usually translates to things like this. Oh no, I mean, they are the same. Does it really matter that much? And yes, you could argue, and that's also what I'm going to do. But all these comments add noise. And the problem when you add all these comments, so first you have the people that think, okay, I had 10 comments, I'm done. Approve. But you also have the people, it still distracts you from the bigger picture, because you start looking at code sign and then you immediately see, oh, I don't like this, I don't like this, I don't like this, rather than I need to understand what's going on here. And I want to go over a set of tools quickly, so I won't go in depth, so please look them up yourself if you find that they're useful, by automatically flagging these issues before the PR is even created. And the first one, I'm not sure, there's also been a deep dive about it, is about error-prone. It's a static analysis tool that detects programming mistakes at compile time. And most importantly, it also provides automatic fixes. So whenever you have a project and you want to start introducing error-prone, you can immediately apply all the suggestions so that it's an easy way to get started with the tool. And to give you some examples of what it does, I also want to mention Picnic here. Picnic built an extra library on top of error-prone with a lot of extra rules, which I found quite useful. I did also work for a time at Picnic and then really got to enjoy them. So to give you some examples, the top one, there's different ways you can do this filtering. You can also say we always want to use objects and then the non-null function. Or we always want to do it the other way around, but at least now we can make a rule and we can be consistent about it and we don't have to have discussions about it. Things about the big decimal. Why don't use big decimal.0? Automatically apply this. You cannot have discussions about this whole thing anymore. And there's more. There's also broken logging and formatting it can actually find. So what's wrong here is that string formatting needs the %s, and whereas most loggers use the curly braces, thank you. Yeah, the accolades doesn't work in English. So this helps you find bugs as well. Or one that I particularly like, what is wrong here?
You pasted it from Microsoft Word.
What? Ah, okay, ignore the quote, that is weird. I think most importantly is that this doesn't do anything because it's usually you need something behind it, right? Assert that, in most cases, suppose it's assert j, but also hemcrest. Dot is equal to or is true needs to be added at the end. And this is something that I came across while introducing these tools, that there were some tests who actually did this. And I find that tools like error-prone really help you in finding these things and also making sure that you don't have to spend attention on this while you do the reviewing because the tool already helps you there. And that's the most important part. You don't have to spend attention or time on this because the tool does it for you. Similar with unused imports, etc. Now, when you start introducing tools like error-prone, or specifically error-prone, test the rules in your code base. So what I came across, we do some weird things with Lombok. Error-prone doesn't like that. So don't do weird things with Lombok, but also keep that in mind, and also things like ignoring generated code. Then there's OpenRewrite, and this is a bit of an odd one out because it doesn't necessarily do checks during runtime. It helps you migrate. For example, if you want to migrate to a new Java version, they have lots of recipes out there to help you. If you do a Spring upgrade still by hand, I would say stop and start looking at OpenRewrite. The same for the Java upgrade. And what you often see is that you have these old switch statements, for example, still around, and you made a change, and now either you actually fix this in that change because you want to do a sort of a rolling upgrade thing, is that you either add a lot of noise to your change or people start asking you to also include fixing this in your change because you touched one line in the file that had the ugly switch statement still. If you use a tool like OpenRewrite, you can just do everything at once and you're done and you don't have to be bothered by it in pull requests. And then I think the biggest source of noise is formatting. And with noise, I mean a lot of extra changes in the pull request that we don't really need. Because the worst example is, of course, two colleagues who have different formatting settings. I think that's the first thing you have to fix. Then, what kind of formatting do you use? And I think the more opinionated, the better, because that leaves no room for discussion. You cannot have discussions anymore. Oh no, you need to add line breaks here, or you don't. Your formatting should be automatically enforceable, and ideally you don't do weird things, because that makes it easier for the next person to be onboarded, and also it makes it easier to automate things. The one that I particularly like, Google has Google Java format, which implements the Google Java style guide. Now, if you don't like Google, it integrates with most editors, and the nice thing is this one is so opinionated, there's only one way or the highway. So if you, it's also not easy to configure. There's, I think, only options to do tabs or spaces. And then there can be, it takes some getting used to, but formatting always takes getting used to. Whenever you're at a new job, you always like the formatting from your previous job most of the times. And the one before, you like the one before that, because we get accustomed to something, but then again, we can also get accustomed to something new. And then we don't have to have discussions about it, and everything is the same. Now, Google Java format doesn't have, I think, a Maven plugin by default, but there's this amazing tool called Spotless, which also integrates with Google Java format and allows you to automatically format your code from the CLI, which means that we can also do it in our build. And then we can say, okay, this pull request, the build fails because it wasn't formatted. And a pull request or our project usually contain more than just Java code. You might have Markdown files, you might have some JSON files, you might have some SQL, some shell scripts. And the cool thing is that this tool actually supports all of them. It has integration with different build tools like Gradle, but also Maven. Go check them out, because I think it's really useful. Just to have everything formatted, then it's also consistent. It's much nicer to read as well. Unfortunately, we cannot all get the Google Java format. I also couldn't convince my team to go for this super opinionated formatter, because there were always scenarios where they didn't like it. Which means that we now didn't have a way to force it. So whenever I had to review a pull request, I had to open the pull request, check it out, format all the changed files, then paste that list of files back into the pull request, like, hey, can you please format these files? Which is extremely annoying. And the way I save time is by automating this. We add a check style with a lot of rules for us, which we found quite helpful. Even if you use Google Java format, tools like checkstyle can be helpful to, for example, check if your constants are named correctly, if your methods are ordered correctly, and it integrates with most editors. Then there is ArchUnit. So who here is already using ArchUnit? Okay, quite some. Who has never heard of ArchUnit before? Cool. Check it out. So the cool thing about ArchUnit is it allows you to, well, enforce the architectural guidelines that you might have, especially if you have a lot of teams and you want to do things in a consistent way. Say you want to do packages. In this example, what you can see here is that if you have a class in source, it should not allow classes, it shouldn't access classes in foo, but it should allow access to target. And you can simply express that in some code. And the cool thing is that the ArchUnit is also the basis for Spring Modulif, which is another project by Spring to get the whole Modulif back. And to give you some more examples, because the foo bars might not be that concrete, say you have this controller, your web layer, then you have some business layer, and then you have some persistence layer, and there's always the classic rule that you shouldn't go up. And this is very easily expressed with a rule in your project. So the first thing you might say is that whenever you have a controller, it should always be in this certain package. And then you can say if it's in this certain package, it should only have access to these packages. And if you make this consistent across all the projects and teams you can have, it's more easy to navigate through them, and you don't have to be bothered about this in your pull request, because how many people are actually looking if things are in the right package? That's sometimes also missed, because it's just part of a file name in the reviewing. And it can help you enforce naming conventions a bit further. There might be opinions about naming interfaces. This is one opinion. There's many. You can also put the I in front. You can also say you should add implementation at the end or impl. In the end, it doesn't matter. It's all the same, but you have to be consistent about it. And the way to be consistent about it is to enforce this consistency, which you can do with tools like ArchUnit. And similarly, like the example I gave of controllers, here you can say, if it's annotated with some controller annotation, maybe you want to use Spring's add controller annotation, which means that you have a controller, and then it should be in this package, and it should not have access to, say, other packages. ArchUnit already has a large set of predefined rules, and it really helps you capture some common mistakes. And when you start using ArchUnit, it's quite easy to create a shared module with rules. The same way we did, and don't try to do all the rules in every single repository, just import them. That also helps to make it easier to migrate from service A to service B to service C as a member. And it keeps things consistent. Now, having covered quite some tools and their order, these tools overlap in some sense of ways. Like you can get unused imports with checkstyle, you get unused imports with Google Java format. No, that one not, but with AirPro you can. Try to define the rules for the tools in a specific order. So the tools that have suggestions and fixes, that one should be the first one to go to configure some changes, because those are the fastest ones, and they can also apply you with suggestions, which I think is most valuable, because that saves some time there. Then anything that you can do in compile time, SonarLint as well is quite useful. And then at the very end, try to implement the rules that you couldn't implement in any of the tools above in tools like ArchUnit. I see I'm going quite fast. And when you introduce these tools in your organization, because you may now have thought, oh, these are all great tools, let's start tomorrow, Monday. With introducing them, don't throw in all these things in the Maven and just everybody has to deal with it. You have to start small. Start with one repository, talk with the team and involve them. What we did when we, for example, started introducing AirProne, we took 3 repositories. We had some simple initial configuration, then we ran it, and then we made a diff of all the changes, and we sort of explained to each change which rule was going on. And we could have some discussion in these example pull requests, whether people liked it or not. And some were arguing, okay, this is weird. So then we had a discussion about it, and then we chose to either enable or disable that rule, so that we could sort of tailor this and the whole team was on board. Because it's important to have the whole team on board, otherwise they'll be constantly at your desk, hey, my error prone is failing, what, why? You don't want that, and the same for all the other tools. Then the other thing is make sure to centralize this configuration. When I joined, we didn't have a parent POM, and this is the best reason to have a parent POM, because you don't want to, especially if check stall, you have a lot of configuration. With error prone, you can have a lot of configuration. You want to centralize this. Now to conclude, write descriptive pull requests. Review them yourself, add some comments. I keep hearing this also from the people who are reviewing, that it's really helpful, and I also find it very helpful myself, because then at the point where I'm about to ask a question, I see, oh, somebody already explained it. Ah, that's why. So useful. Then be specific in your communication, and also be friendly. Really force yourself, and it takes some getting used to find the positive things. Then use these Vue.js features, like the code coverage and your editor, to help you do the reviews and maybe find some extra things that could be fixed. And then the most important one, stop bike shedding, start automating. Thank you. So given that I was a bit fast, we have some time for questions. Are there any questions? Yes. Is there a question? Or there's no question? Ask the question?
Yes. What do you think about disabling white space changes when you do the diff? So you don't review changes where they have carriage return line feed, trading space, and that stuff that doesn't really matter.
Okay, so the question is, what do I think about white space changes in diff? There's always this option to ignore white space changes. I do like to enable the ignoring the white space changes, but if you use all these automatic formatting tools, there should not be any white space changes at all. So I would first go to make sure that they are not there anyway. I mean, you can ignore them, but they're still there. You can do both, but I would argue form others. Yes. Sorry? Okay, so checkstyle doesn't work with JDK 21, you say? Okay. I hope they start supporting it soon. I don't know about that. I think actually it's working, because we run Java 21 and we run checkstyle, and it does work together. I do know that there are some extra changes needed. For example, for error prone as well, you need to do some module info configuration. That can help. Now, there was, by the way, one last thing before you all leave. I want to quote my previous boss and also the person who mentored me in getting into public speaking. Please review, leave a rating, and the quote, be honest, but also be generous. Thank you. And I'll be around in the front, so if you have any questions, I'll be here until somebody kicks me out.
All systems are nominal. Initialize Genesis sequence.